Howdy, it's Tubal Cain again. Today I'm going to talk about taper turning, and I'm going to use the taper attachment method, which I haven't covered yet, but just in the way of review, there are three different methods of turning a taper on the lathe. Number one being the compound rest method, and I have shown that in other videos. Number two is the offset tailstock method, and then the third is the taper attachment method. And now I'm going to give you some of the pros and cons of each method. In some of my other videos you've seen me use this method, the compound rest method, particularly when I made the plumb bob. And to me it's the easiest. Here's some pros and cons. To me it's the easiest method of cutting a taper. It's very fast setup. You can do it just in a matter of a minute or less. You can turn very steep tapers with this method, and you can do internal tapers by boring as well with this method, because you're not between centers. Now the disadvantages or cons is that well, you can't do it between centers or only at certain angles. You lose a lot of the versatility, but more than likely the compound's in the way of the tailstock. You cannot use power feeds with this method, and it's generally for short tapers, like on my plumb bob. You can make longer tapers, but it'll be necessary to change the position of your carriage and make several cuts, and sometimes it's very hard to blend them in. The second method is the offset tailstock method, and this is my least favorite method. And in fact, often we are cutting a taper when we don't want one by this method, by just not having our tailstock perfectly aligned. So in a way it's a nuisance. The pros are that power feeds may be used and long tapers may be machined. There may be other pros and cons for these. These are just ones that come to my mind. Some of the cons are it cannot be used for boring tapers because we're between centers, and we cannot do any chuck work. And it's for lesser degree tapers, shallow tapers, I don't know, I suppose up to 3 or 4 degrees, I'm not sure offhand. We lose our tailstock alignment that we have set on the lathe with an indicator, and most of us would rather take a beating than offset tailstock centers. Math calculations may be required in order for you to set the tailstock to the angle that you want it. And if you are given degrees, for instance 3 degrees, you would have to convert that to taper in inches per foot in order to actually adjust the tailstock offset. And another con is sometimes it's trial and error. You got to take a trial cut and see if you're getting the taper you want. So this is not my favorite method, not to say that it can't be used. The third and final method of turning a taper is the taper attachment method, and I just recently built a taper attachment for my Atlas lathe, and that's what I'm going to show you on the demonstration here in a few minutes. The pros are that power feeds may be used when turning a taper, and long tapers may be machined depending on the capacity of the attachment that you have, and that the commercially made ones are usually calibrated in both degrees and inches per foot of taper. You can do internal tapers by boring. The work, of course, would have to be held in a 3-jaw. You can make match tapers, that is internal and external, and may be turned without changing the adjustment on the taper attachment, so that those two tapers will truly match one another. Because if they're even off 1 or 2 minutes, it may be objectionable to you. And that multiple operations may be performed, and by that I mean you can do straight turning, you could do threading, and other operations while you still have it set up to do your taper. So it doesn't interfere so much, it can just be ignored. The taper attachment can be ignored, and it's not in your way, it's toward the back of the machine. The cons are that this attachment is a very expensive attachment, and it's not always available. So if you have an older lathe, unless you make one like I'm going to show you here in a minute, you may not be able to get one unless you could borrow it off of somebody else's lathe. And that the tapers are limited to about 6 or 7 degrees. You cannot turn real steep tapers with the taper attachment. There's 2 different kinds of taper attachments. One's just the plain taper attachment. The other one is called a telescoping taper attachment. And we're not going to discuss those. Look it up in the South Bend lathe book if you want to read more about that. Now over to the lathe. Okay, here's my homemade taper attachment. It clamps onto the bed, one end right here and the other end here. And then this is the guide bar, and this is the drawbar that connects the guide bar with the compound, or the cross feed. Now we cannot use the cross feed when we use one of these. It has to be disconnected, so in fact the cross feed doesn't do any feeding at all manually. It's all going to be a matter of taking the reading off that guide bar. All of our feeding will be done with our compound, and the compound must be set at 0 degrees, perfectly perpendicular to that guide bar. On this end, we can set the pointer at the number of degrees we want, and it goes to 6 degrees on each side of the 0. Now the entire unit clamps, I said, to the bed, but it can be moved back and forth. And before I begin cutting, I'm going to move it way down close to the headstock. Right now it's just in kind of a demonstration position. My attachment is more or less a copy right out of the book of what Atlas did on their lathes, and Logan did a similar taper attachment, and it swings from one end. This is the pivot, and it swings on the other end, whereas for South Bend and Sheldon and other makes, they pivot in the center and have dovetails and are more elaborately constructed, generally with a reading on one end in degrees and the reading on the other end in inches per foot of taper. Now think of a telescope, or a taper attachment rather, of being nothing more than turning your lathe into a copy lathe, and you're tracing or duplicating the taper that the guide bar is set at. You see the drawbar can be swung in either direction. I've got it disconnected from the point right here. That's the 0 position, and we're going to cut a 3-degree taper, and we're going to set it 3 degrees in that direction of 0. This slide fits on the guide bar and slides freely but with no slop, and is then connected to this drawbar by a bolt, causing it to perfectly duplicate the taper on the drawbar. Now notice that I'll move that over a little bit. The cross slide can move in and out, and you want to make sure that your gibs are set loose enough so that there is no binding, but not sloppy. This particular component here has a dovetail on it, and it's clamped to the dovetail of the cross feed. And as you can see, it also slides freely in here, and that's oiled up nice, but that's a real good fit in there. I have to hand hold the camera here, so it's going to be jerky for a moment. But the first thing you do when you set one of these up is you have to remove the brass nut that controls the cross feed. So that is removed and laid off to the side. Don't lose it. This brass lug here normally sticks up through this hole where my finger is, and so we have a little pin there now that is fastening the drawbar onto the cross slide, and another screw here to stabilize it a little bit. Some of these drawbars that you see, well, I think all of them are slotted, but I just drilled a series of holes on the milling machine instead, and there's probably only 1, 2, or 3 holes here that we're normally going to use anyway within the range of the machine. Here again is the little protractor that I made on the end, and you can see that we can set it. We naturally would never set it on 0, but 1, 2, 3 and degrees and so on. I did not put half degrees on here. We can also set this with a protractor, or if we want to get real accurate, we can set it with a sine bar off of the edge of the bed. For instance, if we were going to do a Morse taper or something that we wanted to be really exact, we might do it with a sine bar. To better illustrate how this thing works, I've got the pointer set at 3 degrees, and I put my magnetic base indicator butting up against the back of the tool holder. And as I advance the carriage, watch the dial indicator. I'm moving the carriage toward the headstock, and you can see it's starting to turn as this guide block follows the guide bar. I know I got a glare on that indicator. If I back it up, now I'm going toward the tailstock. You can see it return to its original position. Now notice as I move the carriage back and forth a little bit, there's backlash. So whenever, and there is on all machines, not just this homemade attachment. So whenever you take a cut with your taper attachment, be sure and back it up sufficiently toward the tailstock before you begin the cut, and that will eliminate the backlash. See this space here and also on the other side? That is what determines the length of a taper that you can turn with this or any other attachment. And I built mine so that I have about 7 inches. If you build one, you could make it more or less. If you're going to turn real long tapers, you could construct it so that there is more space. See, we've got about 6 or 7 inches right in here. When is this guy ever going to cut the taper? I know you're thinking.